Hello, my name is Khalil Stell. I am the president of SJSU Robotics. I'm also the lead of telecommunications. Right now I'm going to show you how our telecommunication system works as well as our video feedback system. Right now I'm going to be connecting up to a server that's all the way in New York. I'm going to test out the greatest amount of latency I can get in the United States. So now I'm going to be connecting. I've created a local instance of the rover on my laptop. And now I will be switching on one of the video feeds. So now I'm going to be switching on the whole view. And here we are. So as you can see, we can now get a little show of me here. And actually the latency can be as far down as low as around 0.1 seconds, so about 100 milliseconds, up to around 1.5 seconds at the worst. We've been able to get latencies around a half second. Now if I bring up the HD camera, so I'm going to bring down this one and then bring up the other one, get a much better picture. The same amount of information being sent over. And the latency is around the same. But another cool thing that we can also do is increase the resolution if we really need to see something, or decrease it on the fly. So right now I'm going to bring it down and bring it back up. The resolution's gone up. The latency is a bit slower, but that's to be expected. And that's pretty much our telecommunications system and how we're going to be feeding back video from the NASA Johnson Space Center over to SJSU.
Hi, my name is Matthew Boyd, and I'm leader of control systems. This is a quick demo of our smart motor controller. The motor controller is located on an embedded Linux device that receives signals from our telecommunications system and directly controls each individual motor. For this demo, it is attached to a temporary vehicle, and here's it in action.
Hello, I'm Alfred Brew. I'm the lead mechanical engineer for the ARM team. I wanted to demonstrate to you guys how we're going to do the universal gripper on our rover. So as you can see right here, we have a funnel, a balloon, and a lightweight material inside that's going to act as our contracting material. And how it works is that we will place the universal gripper over an object, in this case a rock. And then when we suck the air out, the material is going to contract together and get hold of the rock. And we'll demonstrate that to you guys right now. So right there you can see the rock inside, and it's not coming out. And then in order to reform it, we will just simply pump air back into it to get it back into shape, and then it'll be good to go for the next round.
My name is Rosalie Maddie, and I'm the mechanical lead for the SJSU Robotics Club. Currently, I'm in charge of the 3 different mechanical teams: the drivetrain, the chassis, and the sample acquisition, which is the arm that will collect the rocks for the rover. 2 main objectives that we had for mechanical design include modularity and keeping all the parts internal. The leg design for the rover has been made so it could be easily deconstructed and constructed again. And the wires coming from the motor to the main power is all going to be unexposed and ran within the legs of the rover.
In the end, we did not complete our goal. We did not build a fully functioning rover, nor did we build a fully functioning sample acquisition system. This is due in part by unexpected delays in the manufacturing process, such as certain machines breaking down and lack of access to machine shops around the university. We have learned from this, and we plan on overcoming this in the future. So by the time of June 2nd to June 4th, by the time of the competition, SJSU will have a fully functioning rover. So be warned and be ready.